Welcome to This Explainer. You know, we walk around every single day thinking the ground beneath our feet is just static, right? That the massive mountains and those deep valleys we see are permanent fixtures of the landscape. But today we're totally flipping that idea on its head. We are going to decode the dynamic, constantly shifting reality of our planet's geology, and we're going to explore the hidden mechanisms that literally build the physical foundation of our world.
Which begs a pretty direct question right off the bat. Do rocks actually stay the same forever? I mean, think about a massive cliff face, or even just those heavy, solid stones you might have sitting out in a garden. They feel like the ultimate symbols of permanence, don't they? Our everyday assumption is that, well, a rock simply exists, unchanging, enduring through the ages.
Well, surprise, they don't. The reality is actually the exact opposite. The ground right beneath our feet is actively participating in one of the most relentless, ongoing processes on Earth. It is a system of constant transformation. It's just happening at a pace that is entirely invisible to our naked eyes. So what we perceive as completely permanent is, in reality, incredibly active.
Okay, let's dive into it. Section 1. Rocks are not forever. Breaking the illusion.
Scientists actually have a name for this never-ending system. They call it the rock cycle. And simply put, this is the continuous process where rocks change from one type to another over incredibly long periods of time. So it's not a single one-off event. It's a perpetual motion engine driving the geological makeup of our entire world. It is literally the mechanism our planet uses to continuously recycle its own crust. Now, the absolute crucial variable to grasp here is the time scale. We are not talking about days or years or even centuries. We're dealing with thousands, millions, or even billions of years. The sheer scale of time involved here is just staggering, and honestly, it's notoriously difficult for the human brain to fully comprehend. A single rock's transformation is this profound, slow-motion event playing out over eons, vastly exceeding all of human history, let alone just one human lifetime.
Section 2. Journey of a Mountain, an epic tale of destruction and rebirth.
To really visualize how this massive cycle works, let's trace the epic life story of a granite mountain. That's an igneous rock. So step 1. It stands tall and seemingly invincible. But then, the relentless forces of wind, rain, and ice begin to wear it down. This weathering acts like an incredibly slow geological hammer, breaking that mighty mountain apart over millions of years. Next, step 3. Those fragmented pieces wash into rivers, eventually settling in thick layers at the bottom of a lake or ocean. Over eons, the immense weight and pressure from the water and the layers above press those accumulated pieces together into an entirely new material, sandstone, which is a sedimentary rock. But wait, the transformation doesn't stop there. For step 4, as tectonic shifts bury that sandstone incredibly deep underground, it's subjected to intense heat and crushing geological pressure. These forces physically alter its internal structure, creating quartzite, a metamorphic rock. In one continuous sequence, that original granite mountain has been completely reborn twice over.
And you know what? The cycle can be pushed even further. If that deeply buried metamorphic rock gets pushed far enough down into the Earth's mantle and it gets hot enough, it melts completely. It turns right back into bubbling liquid magma. And when that magma eventually makes its way back toward the surface and cools, it hardens into brand new igneous rock, ready to begin the whole epic saga all over again.
Section 3. Tracing the rock cycle, the mechanics of transformation.
Now, what's really interesting about this is that if we step back from the story of a single mountain, we can actually trace 3 primary pathways that govern all these changes. First, we have igneous turning into sedimentary rock through weathering, erosion, and pressure. Next up, sedimentary turning into metamorphic rock through deep burial, immense heat, and pressure. And finally, metamorphic rock turning back into igneous rock by melting completely into magma and subsequently cooling. These 3 represent the major structural highways of planetary geology.
Section 4. Any rock, any path, the anything goes rule.
When we hear the word cycle, right, we intuitively picture this perfect, predictable circle, something moving one step at a time in a neat little line. But our Earth's geology absolutely does not play by those rigid rules. There is no single starting point here, and there is no end. The whole system is entirely nonlinear. The reality is that any type of rock can become any other type. Let's look at the mechanics of this unpredictability for a second. For example, a sedimentary rock doesn't have to just obediently wait around to be buried and become metamorphic. Nope, geological uplift could push it right back up to the surface where it gets weathered by the rain, turning it straight back into new sediment.
Similarly, literally any rock, igneous, sedimentary, or metamorphic, can melt into magma if tectonic forces push it deep enough into a high-heat zone. So the rock cycle has countless possible paths. It functions much less like a single circular track and far more like a massive, interconnected web of geological variables.
Section 5. Deep Time and Science. Seeing the invisible.
The core barrier for us to fully appreciate this process is timescale. A standard human lifetime spans mere decades, while geological time unfolds over millions, sometimes billions of years. We simply do not live long enough to stand outside and watch a mountain weather into sand, or to actually observe a layer of silt compress into solid stone. When we look out at a landscape, we are really just observing a single freeze frame of a feature-length film that has been playing since the very formation of the planet.
And this brilliantly illustrates how the rock cycle isn't just an isolated concept. It provides a foundational key to grasping multiple scientific disciplines. Think about chemistry. It demonstrates the exact principles of matter continuously changing state under varying conditions. In physics, it highlights how fundamental heat energy and pressure dynamics drive these massive physical transformations. And on a profoundly practical level, the weathering of rock creates the nutrient-rich soil and dirt that complex ecosystems and, human agriculture rely upon to survive. Every scientific concept is deeply and beautifully intertwined within the geology of the Earth.
All of which leaves us with a final, rather fascinating puzzle. Since we know the rock cycle takes millions of years, and we know we absolutely cannot stand around to watch it happen in real time, what clues do scientists actually use to figure out how rocks changed in the past? How exactly do we play geological detective with the evidence hidden inside the rocks themselves?